engineers, we care about minimizing the lag between making a change and the feedback for that change. As DevOps engineers, we manage resources. So today we're going to talk about combining different tools to get fast, high quality feedback so we can manage our resources. This project is at 4 different levels. The levels form a pyramid where each level supports the higher levels. Only the top level is important. As DevOps, the top level is our cloud resources, which is the stuff we actually care about. The other levels are different levels of abstraction, from simple code on the bottom to high-level resources important to our business on the top. As DevOps, we care about resources. A lot of times the resources can get kind of complicated, so we're going to use Terraform to manage the resources. So just for funsies, let's make a bucket. The point of this exercise is not really to make a bucket. The point is to get feedback at multiple levels. We're going to get feedback at 4 different levels. One of the levels is just this fast, simple VS Code level, which is smart enough to highlight the different pieces of our code. But it's not very smart. Like beer is not a reserved word yet. The feedback is at the very end. When we actually do create a bucket, we're going to watch the buckets being created in the lower left-hand window. What this window says is currently we have 2 buckets. We have this organization bucket and we have this other testing bucket. In the upper left, what we're going to do is connect the saving of this Terraform file to the Terraform program itself. When we make changes to the Terraform file, we want to get feedback on it in as fast and as smart a way as possible. So we're going to connect saving of the file to running Terraform. We're going to use a tool called Entr. All it does is you give it a list of files and a command, and it'll run your command every time one of those files changes. The point of this is so we can save a file and very quickly get high quality feedback. Generally, as DevOps, we care about minimizing blast radius so that we don't destroy things. Today, we're running a dev account, so we can go ahead and be more aggressive and not damage the real resources. So we're just going to do this. Okay, so now let's save out this file. It's automatically running Terraform, and it's saying, and it's not very happy with us. It doesn't understand beer. So let's change it so that this Terraform file is correct. So we're currently getting feedback at multiple levels. We're getting feedback at the editor in terms of highlighting different pieces of the program. It isn't very smart, like it didn't complain that beer is not a keyword. And then we're connecting the editing of this file to running the Terraform program and getting real output. Let's go ahead and fix this. Okay, so what it says is Terraform doesn't need to do anything because it checked the cloud, and the cloud already has one of these buckets, therefore it doesn't need to do anything. So this is great. We're getting feedback at multiple levels. Let's make a change here. It is now 4:57, so let's do 4:57 and save it. Terraform says, oh, there's something different. The 837 bucket no longer is being referenced, so it needs to be destroyed. And then it says, oh, we now have a 457 bucket, which doesn't exist, so let's go ahead and add this thing, add the bucket. And that's exactly what happens here, is we now have this 457 bucket, but we don't have the previous bucket. What we've done today is combine a couple different tools so that we can get fast, high-quality feedback for DevOps management of resources. As a developer, you would probably say, oh, this is great. We can do a bunch of stuff and then get a really fast feedback. But you have to be careful. For instance, as a developer, it's very common to say, okay, I'm going to work on this piece, I'm going to work on that piece, and you comment out the pieces that you don't care about so you don't get distracted. Let's go ahead and comment out this piece and see what happens. Save it out. Okay, 457 is no longer referenced anywhere. We've commented out. So Terraform very helpfully goes through and deletes our bucket. So now the bucket is gone. If there's any files in there, they're all gone. If this is a database, the database is gone. So what we get here is, even though we have feedback at multiple levels, the editor tells us all of this stuff is commented. Terraform tells us that this is a valid file. Terraform tells us that it needs to do this thing, but this system is giving us feedback for something we really don't want to do. So as a DevOps person, we need to be careful how we set these things up. Right now, we have it set up so that anytime a change is made, we go ahead and apply and make any change whatsoever. Probably what we want to do is do a safe version of the exact same thing. So as a DevOps person, we want to get fast, high quality feedback, but we want to not actually apply any changes until we explicitly say that's cool. So let's do this again. Okay, so let's tell Terraform, okay, no, we don't want the 457 bucket. Let's do the 15 or 1700 bucket. What we did now is we told Entr to run Terraform. We told Terraform to figure out what changes it should be making, but don't actually make them. So it says, okay, we're going to create a bucket. Here are some details of the bucket. We're going to add one thing, change 0 things, and destroy 0 things. And the plan has been saved. So this is great. So we can do like 1701, do a save, and now we're getting feedback again. So this is great. This is nice and safe because our buckets have not changed. If we want to, we can abort this loop and then do exactly what it says here, Terraform apply beer.plan, and then it'll actually execute the plan that Terraform says we want to do to manage our resources. There we go. So right now we have a fast feedback loop in terms of we make a change to our Terraform resource descriptions. This loop will automatically plan our resource changes but not actually apply them. And then we can break out of the loop, and then we can manually make the changes if we want to. Down at the bottom, we have this automatic thing which tells us the results of our actions. This project is at 4 different levels. So the bottom level is the editor, in this case VS Code, which gives us color feedback on our syntax. Above that, Terraform gives us smart feedback on our syntax and also the meaning of our changes. This top level is the only level that matters. And at this level, Terraform is reaching out to the cloud, figuring out what's happening, and then either giving us a plan of how it's going to change things based on our description, or it actually goes ahead and changes it. And this is the only level that matters. Everything else just supports the resource level. The reason we have this pyramid is because each of these feedbacks are at different speeds. The bottom one is very fast. This is real time. Terraform is pretty fast, but it takes a couple seconds for Terraform to give us feedback. This one's the slowest, so this one takes about 10 seconds, but this is the only one that we care about. This is the resource level. What we've seen today is, as engineers, we want to minimize the lag between the changes we make and the feedback of what actually happens. As DevOps engineers, we care about resources like databases and networks and so forth. So we can't just like arbitrarily create and destroy these things. They have state. The technique I've outlined here makes it very easy to get high quality and occasionally very violent feedback based on your actions. So this is actually super fun, and I highly recommend everybody do this as long as you're safe and you don't accidentally destroy resources.